This talk is about why it's interesting to build a new browser engine. And first, I want to give a sort of a historical context for the browser market. And then using that, I want to make a case for a new browser engine. So around 1990, someone wanted to create a web page. And to do that, they had to invent the World Wide Web. Shortly after that time, the first browser was made. And that browser was called, creatively, World Wide Web. The thing about this browser was that it was only for NeXT computers. It had a graphical user interface, but it only worked on one operating system. So the next year, there was a cross-platform browser made called the Line Mode browser. And this was the first browser that was made for multiple operating systems. It worked cross-platform. The thing was, it was text-based. So if you've ever used the browser Lynx, that's a spiritual descendant of this Line Mode browser. Now, just a few years later, another browser was created at NCSA at the University of Illinois at Urbana-Champaign called NCSA Mosaic. And this was both cross-platform and graphical, and it had a killer feature, which was images. And that's why it became one of the most popular browsers very quickly. But it didn't stay that way for long, because shortly after 1994, some people from NCSA started a company called Netscape, and they created the Netscape Navigator browser. And at the same time, this Mosaic browser was licensed to a company called Spyglass, which in turn licensed the technology to Microsoft to create Internet Explorer in the same year. Now, you may be familiar with this story of the first browsers, but the thing is, this isn't the whole story about web browsers. This is just the first paragraph of the Wikipedia article. But if you read down to the third or fourth paragraph, there's another story. And that's that at this same time, there were many other browsers. And they were browsers written by maybe one person or by a big corporation like IBM. And just to be honest, this was just a few of the ones that I found looking around. And some of these browsers were written for particular platforms. Mac www was for Macs. Some of them had very specific features that other browsers didn't have. There was one here that did server-side rendering. Lynx, another text mode browser. TK was written for the toolkit TK. In general, this was a time of incredible experimentation. The web was new. People were doing new things. And if you were one person, you could write your own browser. And out of this experimentation came the first browser wars. Now, there were lots of browsers during this time, but during the first browser wars, there were two major browsers. You probably know this. It was Netscape Navigator and Microsoft Internet Explorer. And the way the war was fought was through features. We saw how with Mosaic, the killer feature images, made it popular. Well, these two browsers introduced features in competition with each other. For instance, Netscape introduced JavaScript, and Microsoft, in return, introduced JScript. And these incredible new HTML tags, Marquee and Blink, came into popularity. These really moved browsers forward. But maybe one thing that stuck with us the most, apart from JavaScript, was cascading style sheets. And there were so many new features that you're probably, if you've been around for a little while, as much as I have been around, you're maybe familiar with these two badges. And we kind of laugh at this today, but I think this is really important. This was something that authors would put on their web page to say, like, look, if you want to experience my web page how it's meant to be experienced, you need to run this browser. And the reason that you had to run that browser was because of the features that it provided. That's how quickly the web was moving forward. And the thing was, the browser war came to an end, and Microsoft won. And they won really big. Netscape, at its peak in 1995, had around 80% of the browser market, an unimaginable number. But in the year 2000, Microsoft, even more unimaginably, had 90% of the browser market. These are numbers that like are imperceptible today. We couldn't conceive of them because the complete market domination of 90% is thankfully impossible. And this situation lasted for a long time, actually. Maybe you remember, maybe you still have scars of this period, having to write a web page for Internet Explorer 6. And the web platform stagnated, actually. The innovation wasn't really happening in the standards body. And in general, if you wanted to see a lot of websites, you just had to boot up IE6. But the people making web pages were hungry for new technology. They wanted to use the web, so much so that they turned to this terrible plugin interface where you could embed native components into pages to give your users extra functionality. For instance, with Flash, you could make animations in interactive content. You could make videos of stick figures doing kung fu. I mean, this was not something you could do with HTML. And things like Real Player allowed you to watch streaming video in your browser. I mean, remember, this was not that many years after Mosaic introduced images. Now you could stream a series of images and watch an entire film. The thing was that Internet Explorer wasn't interested in adding this technology to their browser, and the standards bodies weren't really interested in adding it as well. Now, nothing lasts forever, and in particular, some market changes happened. One is that Netscape had gotten a lot smaller and lost a lot of market share, so it was purchased by AOL, and an open source organization, let's say a nonprofit sort of thing, branched off from Netscape, the Netscape division of AOL. And the idea here was that the open source organization would work on the open source version of Netscape Navigator, and then AOL would bring in those changes over time. But something else happened, actually. A small group of people at Mosaic, at Mozilla, worked on a new project called Mozilla Firefox. And this brought a lot of new features to the browser market. In particular, it had things like tabs, a really focused browsing experience, pop-up blocker, very important. The other thing that happened was that another minor browser called Opera became freeware. And it made this browser much more competitive because now you could try it, you could run it, and just because it was better than Internet Explorer, a lot of people did. At the same time, there was a WebView widget in the KDE desktop called KHTML, and Apple took this widget and forked it into something called WebKit, which was a browser engine, to build a new browser called Safari. Now, Safari was only for Macintoshes, but WebKit became a base for a lot of new open source browsers. And all these things led to the second browser war. And this was basically a period of intensified competition between the different browsers. And what we see in contrast to the first browser war is that it was open source software was a huge player in this. And the companies that could harness open source had a lot of success. For instance, people from outside your organization could fix bugs or even implement entire features. And this happened, actually. And if you were a company that wanted to hire new engineers, your open source component of your software could actually serve as a hiring pipeline. Like if you look at the history of Mozilla, a lot of the people that became well-known Mozilla engineers were actually open source contributors to begin with. We also see, because of this open source nature of the browser market, a separation for the first time between the browser and the browser engine. So WebKit was the browser engine, but Safari was the browser. And Safari was closed source because we start seeing that the browser the browser makers are also service providers. So the service portion of their browser is closed source, while the browser engine itself is open source. And finally, because of this competition, because for the browser to work, the browsers needed to agree, the browser vendors needed to agree on the way the web worked, the standards bodies became much more important. Up until this point, they were doing a lot of things with XHTML, different profiles, things that really didn't matter to browsers, to the web. They were things that other companies wanted to use. But now, suddenly, the standards bodies are working on the web again. And this is how the web evolved. We see that browsers adopt tabs. Now they are made for just browsing lots of web pages at the same time. We see the creation of HTML5, a refocusing of HTML and the W3C through the advocacy of a break-off standards organizations known as WHAT-WIG on web apps and using the web to make applications. CSS advances. We see CSS 2D and 3D transforms. Finally, you can make more rich content with the same web elements, with the same HTML elements that you're using before. Transitions and animations. Finally, these things that Flash offered are available directly in web pages. And this is funny, you may be wondering why I put this minor version here. CSS 2.1 was released in 2011. The web stagnated so much that this was a major thing because CSS 2.0 was released in the 1990s. So that's how long it took to release that minor version. And after this point, versions of CSS were released in a more regular cycle. We see Canvas and WebGL. Finally, you can draw and make calls to the GPU in your web page. We see audio and video. No longer do you need to embed Flash in your page to see video or real player. And all of these features enables the web that we know today. So what happened? Well, this time Google won. And the reason it won was that they created a browser called Chrome, and they based it on WebKit. And it was created in 2009, so sort of near the end of this second browser war. But it quickly gained about 65% of the market share, which is the market share that it has today. But the thing is, like, even though this isn't close to the 80 or 90% that we saw in the second browser war, or sorry, the first browser war, no other browser has over 20% today. So even though Chrome only has 65%, they're dominant in the market. One reason for this is that on iOS, at least today, maybe not tomorrow or the next day, you can't have your own browser engine. You have to use WebKit, and if you embed WebKit, you can't use the fast JITted JavaScript. The sad thing about this time is that during the second browser war, there were a lot of different engines, not just browsers, but a lot of different engines. So re-implementations of HTML and CSS itself. And they almost all died. So Presto, which was the engine behind Opera, was abandoned in 2013. We see Trident, the engine behind Internet Explorer 6 and before, which could track its legacy back to Spyglass, was abandoned in 2015. And Edge HTML, the supposed replacement for Trident, was abandoned in 2020, Microsoft finally deciding just to use the Chrome engine, a decision that a lot of browser makers follow. Now, this is sort of the stasis that we're in right now. The engines are open source, the browsers are closed source for the most part, apart from a few exceptions. And a lot of the browser vendors are also online service providers. And browsers in general are written in C++ because they're legacy software. They're quite old. And this is despite the fact that there are incredibly bad security issues in these browsers. And every day, a security issue in a browser is worse because there are more people using and relying on the web. Because these engines are so old and so big, making big architectural changes is difficult. Maybe if you're going to replace the layout engine in Chromium, for instance, you're a huge company with thousands of engineers working on the browser. It's still going to take you, I don't know, 4 or 5 years, maybe more, to replace the layout engine. So what we see is that innovation is expensive and difficult. And maybe the environment for a new browser engine is tricky. But at the same time, because during the second browser war, the standards body became so important in the process of making a browser, engines are increasingly interoperable and they follow standards. So your page will more likely today look the same on 2 browsers than it would at any other time in history. Yet, in the standards body, the way it works is that if you want to make a new standard, if you want to make a change to a standard, this requires implementer support. So what this means is, if you want that, you need to have browser vendors agree with that change, or you need to make your own browser. So browser makers are the gatekeepers of standards changes. Now, I kind of want to focus on this moment during the second browser war, because I think it's really interesting. So we see that, like, this tracks the market share of different browsers over time. And you can see that there are big changes happening. But there was a great moment when all this was happening where the share was almost equally divided between 3 browsers, with one kind of coming up from the rear, which is Presto, Opera. And it was a time when it wasn't clear how things were going to go. And it really mattered that your page worked on all the browsers, because it would be breaking 30% of the web, maybe, or 20. So I just wonder, like, is there any way we can get back to this moment where the web isn't dominated by 1 or 2 companies? And that's why I think, I hope to convince you that the way to do that is to build a new browser engine. Now, I think if we can look back at the 2 browser wars and at that preliminary period of creativity at the beginning of the web, we see that more competition equals more innovation. And the more people making browsers, and especially browser engines, because the engine is what determines what standards are implemented. It's very difficult to take someone else's engine, make a browser, and put your own standards there, because you have to keep applying that patch to upstream. The more people making browser engines, the less control of standards by a few companies. And finally, a new browser engine offers us a place to innovate. We can make the browser engine work on new platforms that are uninteresting or impossible to use by other browser engine makers. We can implement new web technologies, things that maybe threaten the market domination of browser engine vendors. Those are the benefits that a new engine gives us. If we think, what would be the ideal new engine? I can think of maybe 4 things. And I put them on the slide, funnily enough. 4 things that are interesting in a new engine. One is that it's safe. And this is something that the other engines only provide us because they spend so much money on patching up these old C++ libraries. But maybe there's a way to make our engine safe from the beginning and to not have to pay this penalty when we're building the web platform. We want our engine to be concurrent. More and more devices have multiple cores. More and more web pages are more demanding. We want to spread this load over all the processors to save as much battery life and to make things work as smooth as possible. We'd like our engine to be lightweight. There are new applications for browser engines that are different from browsers. I'm sure you've all used a really heavy Electron app and wondered where all your memory went. Maybe we can build a new engine that doesn't use up all your memory. Maybe because we're starting from the beginning, because we're being smarter about how we build the technology, maybe we can avoid that. And finally, we want to make the engine embeddable. We want a new engine that we make to be usable by people who are making desktop applications, by people who are using the browser engine on the server, by people who are using the browser engine in ways we can't think of yet. We don't want to just build one browser. We want something that can be used in any type of application. Now, I think that the project that I work on, Servo, is a great candidate for this new browser engine. Because Servo is an embeddable, independent, memory-safe, modular, parallel web browsing engine. Let me break that down a little. So, Servo is independent. It was started as a Mozilla research project, and it stayed that way for a while. But now it's governed by the Linux Foundation, and this year the Linux Foundation Europe. Now what this means is that Servo is run by the community. The decisions are made by a technical steering committee. They're not made by any one company. People from all across the industry can join this committee and decide the future of the browser. Servo is also memory safe. It's written in Rust, which brings us memory safety through its borrow checker, its ownership system. We get that for free just by building the browser on Servo. And, sorry, building the browser on Rust. We also get Rust's built-in concurrent data structures. This means that we can easily make our web browsing engine concurrent without having to worry about whether or not we're mutating the memory in 2 threads at the same time, you know, not having to use really finicky pthread APIs. Rust has it all built in. We get that for free. We get to avoid use after free errors and data races. And we get this at 0 cost. If you're familiar with Rust, you know that Rust gives you all these things without the overhead of a garbage collection, and in many cases, you can avoid reference counting. So I think we can agree that Rust is a natural fit for a browser engine. Servo is modular. It's composed of reusable Rust components. A lot of these are available on crates.io already. You can pull them into your own project. If you want an HTML parser, you can use HTML5 the same one that Servo uses. And this is proved by the fact that Firefox is already using components in Servo. Firefox and Servo both share the same style engine, the same selector engine, and this engine is multi-threaded. So it already proves the case that this technology is useful and can improve the situation of browser engines. Because Servo is newer and more modular, it has a smaller code base, components can be rewritten and replaced. Recently, we just replaced the entire TLS backend in Servo, and it was a small amount of work. And I would say that this is this common story in Servo. If you tried to do a project like that in a larger browser, it would be a big effort. In general, a newer code base means that it's much easier to make changes to the architecture. And if you have an interesting idea for how to render the web, Servo is a great place to experiment with that. Servo is parallel. Like I said, devices have more CPU cores than they did in the past. And in most browsers, I would say all major browsers, layout of a page only runs on one CPU core. In Servo, this can happen across multiple cores. And we get to decide whether that happens at runtime and with very little code overhead. Basically, Servo is using parallelism to provide faster and more energy-efficient rendering. And Rust unlocks this through its principle of fearless concurrency. And like I said, this is completely unique to Servo. So what that means is, for instance, in this case, where we have many divs changing their color at the same time, Servo is able to do this in a parallel way that that means that it's happening more efficiently. So like, I want to level with you about the status of Servo. So Servo comes out of Mozilla Research. It was a research project. So it's an experimental engine right now. It's not yet suitable as a general web rendering engine, but we feel that it can be made useful for targeted applications. Now, right now we're working on implementing support for the two hardest parts of CSS2, which are tables and floats. Floats is just about finished. But at the same time, we already have support for advanced web APIs. Servo works across multiple platforms: Linux, macOS, Windows, the major desktop platforms, as well as a bunch of other Linux-like Unixes. And Servo supports embedded platforms. We have support for Android and embedded devices that use Linux as their operating system. And we hope to expand to more platforms very soon. I mentioned a little bit about the work we were doing on web APIs. We do have basic support right now for HTML and CSS, and that's increasing by the day. But we also have support for WebGL right now. So we're able to run more advanced types of applications that don't rely on the huge legacy standards collection that's CSS. We also have support for WebGPU, and that's also improving as we go along. And we hope to be fully compliant soon. Our goal right now is to get new contributors. We really want to reduce the friction of working on a web engine. Now, what this means is we want to be a lot easier to work on than other browser engines like Blink or WebKit. And I've worked on all of those, so I know how difficult it can be for new contributors. We want people to be able to come to our web page, read the documentation, and to make a change, to add a new web feature, and to feel like they're working on the web platform with as little trouble as possible. We want the code to be as simple as possible, to have as much code health as possible. We want to refactor things so they make sense. We want all our data structures to reflect the names used in the standards, so that you can look at the standards on one screen, look at Servo, and know that these two things match up. And when they don't match up, you know that there's a bug, and you can fix that. That's something that's very difficult to do in any other web browser engine today, because a lot of them were written before these standards were written. And we want to gradually increase the amount of the web that we can render. So what this means is we want to finish our support for CSS2, to continue working on CSS3 to improve the bits that we haven't implemented, to finish support for all of the other HTML5 APIs that are out there, and to be useful as an embedded application. Yes, that's true, to be useful to create embedded applications, but also, hopefully one day, to be a general web browsing engine. And we want to make sure that when people embed Servo into their application, that there's a nice API and a stable API they can use to create those applications. This is the thing that makes it difficult to use Gecko today. We want Servo to be useful in that way. So in summary, we want to create an independent and advanced browser engine that disrupts the browser market. And we want to grow a vibrant and active and curious community of web engine developers. So if this sounds interesting to you, if you want to work on the web platform, if you want to make a difference in the web, if you want to do things that are impossible to do if you don't have a huge development machine that can compile Chromium, then I encourage you to join us. Try out an experimental build of Servo. Follow us on Mastodon. Take a look at the GitHub, and chat with us on Zulip. We're super friendly, and we'd love to talk to you and to hear your ideas for the web. So with that, if you have any questions, I'm happy to answer them. Sorry, is there time? Sorry. I did 30. Yeah, I could show some demos. So I can show running Servo. 1 second, I'll put this down. I'm just going to mirror. Actually, if anyone's curious about anything, I can tailor what I show to anyone's curiosity.
大家有没有什么综合的问题，或者是任何有关 browser 任何详细的问题也可以，他可以按照您的问题来秀不同的这个 demo。OK, question back here.
You mentioned tailoring it to people's curiosity. Do you have embeddable examples that show exposing an API to the web code that's being embedded in Servo, like hosting Servo as an embedded thing, providing an API and consuming that from JavaScript or WebAssembly?
So we have a couple APIs, but the big plan for this year is to polish those and to make them usable by application developers. The examples of the API that we have now are, we essentially have two APIs. One is a standard Rust API that exposes Servo through a Rust interface. And the other one is a C API that exposes a simpler version of the Rust API. And there's also a Java version of that written on top. What we want to do is Rust has this issue now where it doesn't have an API. So Servo is a browser engine. It's a small one, but it's still a browser engine, which means that it takes about 30 minutes to compile, which is 2.5 hours shorter than a normal C++ browser engine. Yeah, we think this is too long for application developers. So our goal for this year is to make the C API the standard API, and to ship a shared object of Servo, and then put a Rust API on the other side of that C API barrier, so that you'll be able to, we hope, pull down a compiled copy of Servo and to write a Rust application on top of that.
What's the binary size for that?
I can take a.
Yeah, how big is it?
Yeah, I can take a look right now. Let me just share this. All right. Display. No. I'm in accessibility. You'll have to forgive me. I typically use Linux. All right. Okay. It's 104 megabytes. So we haven't done much optimization on the binary size. But the way that the web works is that you have hundreds of DOM APIs, basically. And each of those is a Rust file. And this is one reason why web engines are so big. But we'd like to make it smaller.
Answer your question? Size.
Does it compile to WASM and can run in itself?
We have never tried, but that sounds like a really interesting experiment.
You mentioned updating the TLS backend. So are you using Russells now?
We're using Russells.
Cool.
Yeah.
That might also factor into that number.
Is it-
OpenSSL would be dynamically linked, right?
Yes, that's true. Yeah.
That's the sort of hit you have to take when you use Russells.
Yeah, I mean that is sort of the trade-off. When you start using more Rust libraries, you have fewer DLLs, but you have a larger binary size. And I mean, I think it's interesting working on Servo is sort of a legacy Rust project. It was made almost concurrently, originally with Rust, around 2012 or so. I think it started. It's interesting seeing like how much of the native code is now much more easily replaced with Rust. And Russells is a great example, but this has been happening like consistently throughout the history of Servo. So I think it's a testament to how much Rust has matured itself.
Okay, I have a question. You mentioned earlier the separation now between the browser engines and the actual browser shell or the UI. What about Servo? You mentioned Servo as a browser engine. Is there also a Servo browser shell currently or in development, or how's the state of that?
So like a lot of browser engines, we have a minimal shell that we use called Servo Shell. And this is really meant for testing and for running what are called the web platform tests. The way that testing works on the web is that there's a huge repository of 2 million tests. And the more of these you pass, the more of the web you're compatible with. And Servo uses this shell to mainly run the tests, but also as a miniature test case. So if you're going to write a full-featured browser, you would have to write a full application around the Servo API.
So when you're looking for contributors, you're looking for contributors on both the shell and the engine, I assume? Or
Yeah, I think like, especially as we work on this API piece, we'd really like to make it. We'd really like to make the API something that's not too strange. I think like the Towery folks have a cross-engine web embedding API. We'd really like to make Servo fit into a world like that. And if people want to build a browser around, for instance, one of these APIs, it would really be a great test case for Servo, for instance. But yeah, we're always happy to have people use Servo in different ways. And I think that if people are using Servo in an interesting way, that's going to give us a lot of motivation to work in that direction to make sure it works good. Because right now we're implementing support for CSS standards, but if someone comes along and says, hey, we really want Servo to do this maybe, or I have this interest, I'm interested in using it for this application, I mean, that brings a lot more people, that brings interest to that kind of use case.
more questions here?
I'm kind of curious what the state is of some of the things. So there's layout, there's CSS, there's like CSS resolution, then there's like the rendering of the CSS, the compositor.
Mm-hmm.
What is like as someone building renderers,
Mm-hmm.
what are the most functional and like least functional bits of Servo that I can like rip out and use my own projects?
Right. That's a great question because Servo is a bit weird for web browsers. So I'm sure you've all seen this web browser called Ladybird, which is a really cool project, another new web browsing engine. And Ladybird has pretty good support for CSS too. Better than Servo's right now, for the moment. But some of these things that you maybe build later on in the process of building a web browser, Servo built from the beginning. So we're working on CSS2 support, that's true. But we also have a fully GPU-based rasterizer. We have parallel layout. We have a multi-process architecture. Some of these things are probably more things that you could use if you are writing your own non-web application engine. In particular, I think the rasterizer is one of the best in the industry right now. This is also shared with Firefox. So.
So Mozilla is clearly interested in Rust and clearly interested in sharing code with you.
Mm-hmm.
If if we would see like more development on server in the future, where do you see it going? Like, is it likely for Mozilla to just pick up more and more of the shared work and eventually Gecko takes over, or does it? Is it more likely for server to go into that direction? Yeah. What's your prediction?
Yeah, that's a good question. So the current state of things is, just for some background, Mozilla pushed Servo out on its own, and it became a community project. But at the same time, Gecko is still using some of the Servo components. And we have a really friendly relationship right now with the Mozilla developers. We sort of share maintenance of a lot of these shared crates. Some of them are, there's like a spectrum. Some of them are more like in the Gecko world, and some of them are more in the Servo world, even though they're used between both browsers. So our hope is that we can continue working together with the Mozilla folks. I mean, we have personal relationships with them. We meet them at conferences, and we make decisions about how to maintain the different crates. And we hope that this relationship will only grow stronger. And I don't think that Mozilla feels threatened by us. And I think they share the same vision of an open web and a web that has multiple browser engines. So I feel like there's not any risk of Mozilla shutting us out or us feeling like we need to shut Mozilla out, and that we can continue with this shared maintainership of our shared crates.
More question? Okay.
Yeah, thank you. You've been here for a couple of days, Martin, I know, and I think you've tried some of the apps to get around here in China and others, and this is where kind of this idea of mini apps were invented, and that's now also something that is discussed on TPAC, like as a standard. Do you see opportunities for that? And
yeah, I think use cases like mini apps are the most obvious use cases for Servo, because when you can, rendering the general web is a big problem. It's a hard task because there's 30 years of content and people write all kinds of different content. Pages with 10,000 divs, you know, you have to make sure that works. But when you're writing a mini app, you're writing a very specific piece of web content. And those are the kind of applications where you can say like, okay, this almost works, we need to fix this, we need to do that. So I think that's probably where the near future of Servo lies, if it's going to be a useful web rendering engine.
Any other questions from anyone? Do you have anything else you want to share? Or?
Yeah, I can load up the demo page, I guess, and show some demos.
Sure.
This is let's see. All right, if this, I'm not on the Wi-Fi. I don't have a, is it here? Connect. Yes, I think it, yeah, no. I think we're good now. Oh, do I need to? Just close. See if this works. I think it's fine. Should be okay. Am I connected? All right, yeah, so yeah, we have a series of demos here. If you use Servo, this is a good page to go to see just what we can do. This is the WebGL demo I showed before. Sorry about the flashing. But yeah, so you can see that like Servo supports WebGL. And this is the Mosaic. This is a Mosaic demo. So this is sort of demonstrating Servo's support. Each of these is a div, which this is a terrible way to write a web page, but a great way to demo how fast you can lay out many divs. Yeah, and this is interesting because other browsers have been optimized for many years, but Servo hasn't really been optimized. This is just with our parallel layout system. Yeah, so you can see that like the parallel layout really allows you to move these things around a lot without jank. Let's see if this one works. So this is a photo gallery demo. There's some debugging output that I forgot to remove. Yep. And I mean, if you wrote a naive implementation of a web rendering engine, you would probably not see this sort of performance. This, we're getting this because we do parallel and because we have a GPU rasterizer. Maybe one more, the div waves. Let's see if I load it again, take the full screen. Each of these, each of the lines here in this demo is another div. Yeah. This is one of my favorites. Classic, in memoriam. I believe we get up to around 200 something before it is out. So these demos are pretty interesting because when they were written, Servo did really, really well, and it's taken the other browsers a while to reach the same performance level. Yeah. Yes, sorry. Yeah, so this is adding, I believe, divs onto a page and animating them, and each one is increasing the amount of layout that has to happen before the page is rendered. Yeah, yeah. It's a bit like if you were going to do this for real, you would probably want to do this on a canvas so that you don't have to keep laying these out. You can see that the frame rate is dropping. That's because there are literally almost 700 divs on this page. Yeah. It's about done. Well, yeah. But again, like, feel free to download Servo and try out these demos. File a bug. The web's not going to look great right now, but every day it's going to look a little better because we're working on it. So, yeah. Are there any more questions?
Any more questions? 还有没有任何问题？